But yeah, so we are going to be talking about conditionals. And conditionals in JavaScript allow our code to make decisions. And everybody here might already be pretty familiar with it, but we're gonna go through it baby steps anyway. But yeah, so they are things we can add to our code where we can put in a certain input and then our code can make a decision based off of that input, which is really where our code starts to get power, because so far JavaScript has only been kind of a static machine where we build it. And, and when I say machine, I'm talking about our functions. So when we write JavaScript functions, they so far have been static because we tell them to do one thing. Even if we pass a certain parameter in there, there's a little bit of variation we can get, but they're only going to take one action or a certain, set of steps that we've laid out in that function, and then give us an output. So there is some variation within there that we can do, but we really get a lot more power when we use conditionals. And they basically, we're going to look at some examples and write some here in a second, but it's basically just saying like, if this thing, then go ahead and do that. Otherwise, do this other thing. So, we use that kind of phrasing all the time. Like, if you don't stop fighting with your sibling in the back seat, then we're going to turn the car around and not go to Disney World, And that's basically what conditionals boil down to. So it's pretty straightforward. And the syntax is also very human readable, which is great. So yeah, we are going to jump into some examples here, and we're going to be using coffee as our little metaphor for today. So hopefully this isn't, hopefully it's not crazy over the top. Yeah. So
Star Wars.
What's up?
Not a Star Wars reference.
Yeah, I know. Seriously, every time I try to come up with a metaphor, I'm like, oh, like immediately a Star Wars metaphor pops into my head, and I'm like, okay, I got it. People who don't like Star Wars are gonna be like, this class blows. Okay. So yeah, we're doing coffee today, and we're gonna have everybody pretty much follow along throughout the whole thing, so that way I'm not just talking at you guys. So if everybody wants to pull up a browser, just pull up a Chrome window, new tab, doesn't matter. It could even be an existing tab. We're just going to use this to get into the developer tools. So pull up Google Chrome and then do a little right click. And actually, let me close this. So right click anywhere on your page and go ahead and click inspect. And it doesn't matter what window it's on, as long as it's just in Google Chrome, because we're going to use like a separate pop-out window of the developer tools. So then you should see something pop up here, your console or your elements pop up on the side or the bottom of your screen. And what we're going to do is we're going to hit the little three dots in the top right here. And we're going to go ahead and select this undock into separate window option from the dock side. And this is just going to allow us to basically have all of our dev tools completely, totally up in our face on a separate window or in a full window, which is actually really nice. So I don't know if you guys have done this before, but if you use dual monitors, this can be really handy for debugging and writing front-end code when you can break this out into a separate window, because then you can just move it around and you can see your full website, on another monitor or whatever. So it is handy to move this around. I like to move it a lot. If you're working on something that's kind of a mobile look, you could do the dock to the right and then have a, more skinny vertical piece. Or you can do the full side. But today we're going to do the full side because we're just interested in JavaScript for right now. Now, one of the things we're going to use in here that I actually just learned about recently, that's a really cool feature of the dev tools, is something called snippets. So to get to our snippets, we're going to go to sources tab, and go ahead and let me know if anybody is not able to see the same stuff that I see here, just to make sure we're all on the same page. So at this point, we should be able to open the sources tab, see what we got here. And you're probably going to see something like this on the left-hand side, where it just shows a bunch of like clouds and then little, basically sources for where the data for the website is coming from, whatever site you happen to be on. Okay, I'll take your silence as a yes. So now what we're going to do is you should see a little double caret to the right of page and file system, or whatever you have here once you're under the sources tab on the left-hand side, this is basically just a file explorer. So in this little file explorer, let's go ahead and click on snippets. So what snippets is a really, really, really awesome thing that Google Chrome has given us and the developer tools give us, which is just a playground. So this is a playground for writing JavaScript. So what we can do here is, I have a few here from some like coding challenges that I've done online. just to test out ideas. So if you learn something new where you're like, oh wow, that's a really cool way to reverse a string, or I can do string concatenation this way and that way, and you want to have like a little comment, and then you have your code, and then you have examples. If you just have little pieces of code that you want to remember, that's why they're called, this tab is called snippets. This is a great tool to use to test those out and to save them, and then to also be able to run code, and you can rename them whatever you want. So we're going to use snippets. We're going to click new snippet, and we're going to name this one conditionals. What the name doesn't really matter. You can leave it as, new snippet or whatever. But basically this just opens up a new tab of like all your different snippet files. And this is a place where you can just write JavaScript, and you will get output in the console. Command K is a good shortcut to clear your console if you had a bunch of crap down there. But you can also right click and then clear console. I like to do that just so I have a nice clear view of what's going on here. So make sure you have your console open at the bottom. If you don't see this console tab in this like little separate window in the bottom half of your screen here, go ahead and hit escape. Escape is the key to toggle the console in the developer tools. So that can be handy if you don't see that there. So make sure you have your console available, and then you have your file, your blank file here. And just to test it out, let's go ahead and write a console.log. This is a snippet. Cool. Now we don't see anything immediately happen because we have to run our code. So in the bottom here, you'll see a little play button with the shortcut command plus enter. So we can hit this to run, or we can hit command enter to run, and we will see console output from what JavaScript we have written here, which is an awesome tool to obviously prototype things and whatnot. So once again, let's try out that little shortcut key to clear our console now. So let's hit Command K. Command K is clear. Just imagine clear spelled with a K. Or right click clear console. Okay, so let's delete that. So we know that it's working kind of as we expect. But we want to write some code here to learn about conditionals. So the first thing we're going to go over is a JavaScript recap. So we're going to go over some of the things that we need to kind of put into place here to learn conditionals, but we want to go back over, what we learned last class, especially because it was so long ago, over the holidays. So let's start out with a recap on variables. So like we talked about, variables are containers for values that we want to store. And we are going with a coffee theme today. So let's say that we have some nice Sumatra coffee beans, I think I'm saying that right, that we want to store in a container. So if we wanted to do that, we're going to start out with const. This variable is going to be a constant. We're going to call these fancy beans, because I think Sumatra is fancy coffee beans. Okay. So we're going to call these Sumatra. If you know of any other types of fancy coffee beans, put that in there as a string instead of Sumatra. Kyra, is Sumatra fancy? Is it not fancy?
I have no idea. It
I
sounds
literally am
fancy.
It does sound. It sounds like it doesn't come from America. I'm pulling these out of my brain from like I've seen on the shelves at Starbucks. That's
Yeah.
all I know. Okay, so we have some fancy beans. And what we're doing here is let's go ahead and I'll have you guys do this as well. So follow along with me, write a comment above this. So we want to explain what we have here. So this is a variable declaration and assignment. So this is kind of that double whammy of two pieces put together. So which piece is the variable declaration and which piece is the assignment? Let's see. So this piece here.
Yeah.
Go ahead, Travis.
I was just going to say that the first part of that is the declaration, and you're assigning the value of Sumatra to the declaration, right?
Yep, exactly. Yeah, awesome. Yep. So I actually was reading an article recently. I found a blog of this dude who tries to write a bunch of interesting metaphors for like beginner programming stuff, and he was thinking about this kind of like a truck. So it's like this is a flatbed truck. When you're doing variables, you think about everything to the left of the equal sign as like a truck with a name. So it's like we have a moving truck named Fancy Beans here. And by doing what's on the left of the equal sign, we're basically just saying it exists. We're building the truck, bringing it into existence, but it's empty and it's there. And then the equal sign is like a little loading ramp that like comes off the end. And then we're loading up the value that's on the right-hand side of the equal sign. And in this case, it's a string Sumatra. And we're dragging that into this container, into this little truck. And then, you know, if it gets reassigned, it's like we're unloading it and then loading up a new value. So I kind of liked his little example of thinking about the equal sign like a truck loading ramp, especially because it visually kind of resembles that, which is fun. So, but yes, good job, Travis. That is exactly what we see there. Okay, so let's do another variable. This time we are going to do a less fancy bean. And we're going to do it with a let. So we're going to call let any bean. You can name it whatever you like. And then we're just going to throw our kind of end of our statement there, which is a semicolon. So what we've done here, go ahead and add a little note if this is helpful. So this is just a variable declaration. This is nothing else than a variable declaration. So we've declared any bean. So we basically said to JavaScript, like, hey, keep in your, oh my God, my cat just almost killed herself. But we're basically telling JavaScript, we're going to be doing something. We need an allocated space. It's like reserving a storage unit. We say, okay, we're going to be using a variable called any bean, but right now it doesn't have anything in it. It's just an allocated slot that we'll use later on. And to check out what that looks like, let's do a quick console.log on any bean. So this is just an empty thing. It has nothing in there. So what do you guys think this is going to print out?
Null.
Null. Okay, so Kyra thinks null.
Yeah, I think
Or
it'll
not
print an
default.
error. Yeah.
Print an error. Okay. Let's see what happens. So null or error is our guesses. Cool. So let's go ahead and hit Command Enter. And what we get is undefined. So this is pretty descriptive. The term undefined is actually really descriptive because we haven't given it a definition. We haven't defined like what it is assigned to. So that happens later on. Now, if this was this, any beans with a bunch of Z's, what do you think this will print?
An error, or it'll
Okay.
say no such variable exists or something like that. I don't know the
okay.
technical terms.
Cool. I like it. Let's see what happens. Oh shoot. Okay. So this is actually funny. So this is coming from line 1 of our code here. So can anybody tell me why we got this error? It's actually line 2, but it's not taking the comment into account. So why did line 2 const fancy beans equals Sumatra throw an error when I ran it like a second time, but not the first time? This is a little bit of a trick question, a little bit of a gotcha. But what separates a let from a const when we're talking about variables? How are these different? You guys remember?
Const is it's not going to change right throughout the entire code, but let, I don't know.
Let can be. Yeah, you're totally right. You're totally right. And when we say change, we're talking about assignment. So let can be reassigned and const cannot be reassigned. So what this sees is that it sees that we're trying to reassign fancy beans, even though it's the same value. Basically, as soon as it sees this equal sign after a constant that's already been declared, it's like, nope, you can't do that. You got to stop. It doesn't care if what follows the equal sign is actually identical to its previous value. It's still a reassignment to memory. So it says, no, you can't do that. So because this is the same like piece of memory in JavaScript that we're working with when we're using this little snippets file, it tells us we can't do that, which is kind of a pain in the ass when you're running a bunch of different tests here for const. But let's see if we can turn off that issue. Actually, no, we'll leave it. That's okay. That's okay. We are just going to comment it out. We may need to change this to a let later on just so that we don't get a bunch of errors popping up constantly. But okay.
Mode, you just don't use const and just always refine it every time you rerun.
If we don't use const, Joseph?
Yeah, in this type of
mode. That would work. Yep. I'm wondering if we can turn off strict mode too. But yeah, you're right. We'll just go ahead and roll with let for now since we don't want to be playing around with a bunch of that stuff. But that's why that happened, because it was trying to reassign or a const. That's why it says identifier has already been declared. So it says you already declared this. You can't do anything with this constant. So, okay, if we clear that, now let's run this again. So Travis thought we were going to get an error from this, which is correct. So any beans is not defined. So we haven't even defined this variable. That is definitely what we expected to happen. So we have declared a let here. And now the next thing we want to do is we want to assign it a value. So if we were going to assign any bean a value, we don't need to use the let keyword, because we don't need to declare it again. It's already been declared. So it's already in memory. So by saying let any bean, semicolon, we're saying remember this. And then on line 6, we say any bean, and it says, okay, I remember that. You know, I know what this is. When you type like a plain, you know, piece of text without strings around it, it's just going to assume that's a variable, and it's going to look for where it is. So it finds this. So we say, okay, cool. Here's this empty container, but we want to assign it. We're going to do a string here as well. We're going to call it Dunkin'. So these are Dunkin' Donuts beans. Okay. And now if we console log that, I kind of want to, yeah, we'll bring that back as well. So if we console.log that, it's obvious what we're going to get. We're going to get Dunkin'. Any bean. Cool, cool, cool. Fancy bean has already been declared. Oh my gosh. This is killing me. So it's still remembering the constant. So I'm actually just going to rename this so we don't run into this problem. So fancy coffee beans. Okay, sorry guys. Now if we run that, we should be good. Okay, cool. So now we see Dunkin' get spit out. I'll let you guys catch up to what I just edited. Oh, and this is super tiny. Sorry about that. Whoa, that's way too big. Oh no. There we go. Is that good? Is that better?
Yeah.
Okay, sorry about that.
So for like snippet mode like this, it's probably better to use var. Make rerun easier.
Yeah, so probably not var, probably just let. So let and var are kind of like, you know, like intergenerational siblings, where var is the old one and let is very, very similar to var. The only difference between the two is the scope of what they have access to. So let is a little bit safer than var, because let only references, it can only access the scope of what's inside of its own block. So a block, and we haven't talked a ton about this, but a block in JavaScript is really just anywhere that an open curly brace and a closed curly brace happen. That could be an if, a conditional statement actually creates a block, could be a function, could be an object. Anywhere you have a block that's going to create scope, that variable is only defined within that block when you use let. When you use var, the scope is broader. And I think it goes to the window. I'm actually not 100% sure, but basically with var, you have more chances of running into conflicts because the variable lives in a greater scope than with let. With let, you have a smaller, more focused area that it exists in.
Python has stuff like that too to watch out for. I gotcha.
Cool, cool. So I would say, yeah, let's just use let going forward. The only reason you would ever want to use var at this point in time is if you're working in a legacy code base where they specifically want you to write ES5, which is the old JavaScript. So almost never use var. I would just avoid it if you can. But we call them variables, and that's just kind of the name that encompasses constant let now. Okay, so we got our any bean spit out. Everybody knows what we're doing. Very cool. Now, because any bean was assigned with let, if we were to do something like this and say any bean, let's make this a better bean. So let's make this, okay, what's a fancier coffee bean? We got Sumatra. We got, oh, okay, there's Arabica. That's one I've seen at Starbucks as well. Okay, Arabica. Unless somebody has a better one. So if we do this, shouldn't have deleted that console log. What do you guys think this will give us?
Both variables.
Okay. So Travis thinks we'll get both variables.
Any
other guesses?
I think we'll get The second one.
The second one? Okay.
Yeah.
Which is a string Arabica?
Yeah.
Okay. Joseph, you want to throw your hat in the lot? No worries. Okay. All right, let's see what happens. We're going to run it. All right. So what we got, and sorry, this is confusing. So let's clear the console. That's another important reason to clear the console, is because it's going to load up what you had before and what you had previously. So now that I've cleared it, let's run it again and see what we got. Okay. So Cairo was correct. We only got Arabica. The reason is because on line 8, we aren't just doing a declaration of a variable or an assignment. We are doing a reassignment. So this is a variable reassignment. So reassignment is when we remove the previous value and we are replacing it with a new value. So a variable is only ever going to contain one value at a time. So because we did this on line 9 and we had previously assigned it on line 6, line 9 overrides it, and it just removes everything that was there before and it puts in a new value. So when we reassign this Arabica, we got that. So this is a little variable reassignment. I'm going to put an extra comment here to say this is a variable assignment. So we have examples of declaration, we have examples of assignment, and then we have a little example of a reassignment. So we're getting through most of like the fancy business that you can do with variables at this point, which is fun. Okay, cool. So we're looking at reassignment. Now, let's continue our recap and get into functions. Oh my goodness, what is happening? I thought I paused the debugger for some reason. Sorry about that. Okay. So now we're going to look at functions, do a little recap on this. And these guys are going to definitely use these. We're going to use the variables we created up here. So make sure you have at least one bean variable going. Cool. So functions. Functions are the foundations of our JavaScript code. They are the machines that we use to complete tasks, manipulate things, and handle repetition. So we're going to go with our coffee theme. We're going to build a coffee machine for our new beans that we've just made. And our coffee machine is, it's not going to be one of those lame Mr. Coffees. It's going to be one of these epic, this image is from Germany. I don't know why, but you know those waiting room coffee machines that have hot chocolate and like the little plastic slidey door and like all the stuff have in the cafeteria at school sometimes? We're gonna make one of those. We're gonna make an epic one. We're not gonna make some stupid Mr. Coffee. Cool. All right, so to start out, we are gonna write this function as a name function that's assigned to a variable. So usually this is how you'll see functions created in modern JavaScript. So we're gonna start with a const. And actually, you know what? I'm going to do a let because of this snippets environment is a pain sometimes. So we're going to go ahead and do a let. But normally you would default to using a const if possible. So use a const until you get errors, and then evaluate if you should make it a let or not. So in this case, we're going to start with let just because of the environment. So we're going to call this mega coffee machine, and you can name it whatever you want. So let mega coffee machine. So this is a variable, right? This all looks like a variable so far, but instead of assigning it a value of string, we're going to assign it to a function. And the syntax for a function is an open and close parentheses, and then we do an arrow, which these are referred to as fat arrow functions. I don't know why, because it doesn't look like a fat arrow to me at all. It looks like a skinny arrow, but they call them fat arrow functions. So we're going to do that, and then we do bracket bracket. So this
maybe it's because it's not just the caret. Because
right,
if it was
not
just
like
a caret, yeah.
Or this.
Yeah.
That's fair. Yeah.
Just a thought.
I guess. Yeah, maybe, you know, I like that. I like that. So we have our fat arrow, and then we have our bracket bracket. So this is a completely valid function. So we've already written a function at this point in time. It's a little condensed, and it's like ugly, and it doesn't do anything, but it is a function. It's a function which is assigned to the variable mega coffee machine. And I know that sometimes this is like gets a little mind melting when you start seeing like equal parentheses equal. You're like, oh God, what is happening? But all you really need to remember and kind of start training your brain to look at these things is that this is your function. This is a little piece that's just your function, and it's assigned to a variable here. So the reason that we assign it is because you can't really reuse a function, an anonymous function, if it doesn't have a place in the memory where you can go back to and get it from. You know, it'd be like putting it in a junk drawer way in the back where you can't, you know, it's not organized, so you're never gonna be able to find it again. So this is us assigning a function to a variable. And you'll often hear this called function declaration, or function initialization, but we'll just talk about it as declaration right now because we're declaring it and we are assigning it. But usually when you're looking online, then people just call it function declaration. Okay, we got mega copy machine. Sweet. Now, if we wanted to use this function, what do we need to do? Do you guys remember the word for making a function happen or bringing a function to life, as it were?
To execute it.
Yeah, exactly. Yeah. So we need to execute the function. There are a few other ways to phrase that. I don't know why there's so many words for it, but execute is definitely one. So we would execute the function. Can you guys think of any other phrases for what it's called? What it's called?
Initialize?
I just said it. I said call. Not initialize.
Oh, call.
No. Yeah. So calling the function, or so executing it, calling it, or triggering it. So we're going to make the function happen by, do you guys remember what we do here? I remember the shape of a trigger, like a gun has a trigger. When you fire it and actually make it happen, trigger kind of looks like a parentheses, right? So when we trigger a function, we just throw some parentheses on the end of it there. And this is also called a function invocation, or invoking a function. Probably too much. Yeah. Let's just say call function. I don't want to overwhelm you guys. So call the function. Perfect. So if we do this, this isn't really going to give us anything because we want to have something spit out to the console. So could we use a console log here? Like this? Do you think this will work?
No.
No? Why wouldn't that work, Kara?
Because you've already called the function, so you don't need to console log it.
Okay.
Maybe.
Okay. We have called the function without the console.log, but if we do, let's test this out. So one of the other important pieces of a function is the return statement. So without a return statement, a function is never going to give you anything back. It's basically like if you had your fancy coffee machine, you push all the buttons to get your stuff, and then it spit the cup out and like filled it up with hot chocolate and espresso and all your stuff. But then the little plastic door, little slidey door, never opened up and it just stayed closed. That's what a function is like without a return statement. It's just basically that, like, it did a bunch of stuff, but you'll never be able to get it. So return is the slidey door opening up and giving you something back. So let's return a string. It just says done. So this function doesn't do anything except for say it's done. But if we were to just call this function, then I knew this was going to happen, and this is also a little bit interesting and a little bit confusing. So since we're inside of a developer environment in the dev tools here, it's actually giving us, it's spitting this out, even though normally you're not going to get anything into the console. Like if you have a function that returns a value in a normal program, it's not actually going to log it to the console. The reason that it did this is because this is a test environment, the little snippets environment, so it knows that we're practicing code. So it kind of does that by default. I know it's a little confusing, so I apologize for that. But normally this would not do anything. This would not spit it out here. So you would have to do this to actually get it to the console, because your console is a place where you want to be able to spit out values and debug and find stuff. If every time you return from a function, it logged to the console, it would be just bananas. You wouldn't be able to read anything. Your console would just be so full of crap. So this is a playground environment, and that's why that happened. So doing it this way would actually print that out. Console log copy machine done, and you'll actually notice that it's not a string here. It's actually well, the type is a string, but it just prints out specifically just that text. So it's a little bit different, but this is what you would need to do to actually get it to log to the console. Since we're just messing around though, and visually it might be a little bit easier to understand we'll go ahead and roll with this. But just keep in mind that returning does not mean it goes to the console.
Okay.
So return doesn't automatically print to the console. Just a note to keep in mind. But because of the playground environment, it will. Okay, so Mega Coffee Machine is doing something now. Fun. Alrighty, so if we wanted this function to return our coffee beans, how could we do that? You guys remember if we just said, okay, we have a function Mega Coffee Machine. I just want to dump the coffee beans in the top and I want them to just fall through all the way through and just open the door and spit them out. So I just want to put the coffee beans in, get the coffee beans out. Can you guys think of any things we could do here?
Instead of return, well, return done, do return any bean or fancy coffee beans?
I like it. Return, yeah, let's do any bean. Okay, so return any bean. Okay, let's clear our console. Awesome. Yes, so this did return any bean. The reason it was able to do this is because the variable was declared outside of the function. So this had access to this. This is what they call this scope. Every time you see brackets like this, there's some kind of scope that's created. And it's basically like a telescope where it gets smaller and smaller. So anything inside of here has access to what's outside of it. And anything here would have access to what's outside of that. But it doesn't go inwards, basically. So if we declared a variable inside of here, like secret equals decaf rules, and then we did a console.log secret. What do you guys think we would get here? And sorry, this is a little bit of a tangent, but this is fun. So what do you think console log secret is going to do?
That's gonna print. Oh, because that's a let. So secret equals decaf rules return any bean. So I think it's gonna print Arabica again.
That's definitely true. Yes, you are right. It is gonna print Arabica. As long as we invoke the function here. So I did just change this really quick. So yeah, so we're still invoking the function. Before we actually invoke it though, we're trying to console log this secret here.
Right.
So actually, to avoid confusion, let's say we didn't even have those two pieces and we just had this.
Okay.
What would this print, do you guys think? And I don't have to leave you guys hanging for a super long time, but the key is about where it's defined, not about how it's defined or how it's declared. So we declared a secret inside of this function. Go ahead, Kara.
Would it print an error?
Okay. Why do you think it would print an error?
Because it was declared inside a function and not outside of it.
Right. And what is the term for where when you're talking about where?
Scope.
Yeah, that's the scope of where this is happening. And scope really just boils down to curly braces, where it happens in the curly braces. So because we declare this inside of these curly braces, it's only available inside of this building. Or building inside of this function. I was going to use a metaphor and I just threw it in there. But it's like if somebody was inside of a soundproof room and they were trying to yell, something to you, you're not going to be able to hear them. But if somebody else was inside that soundproof room with them, they would be able to hear them. So console like secret here is going to say secret is not defined, which may seem counterintuitive because you're like, it is defined. I did define it, but it's not defined in this scope here, because this is a secret soundproof room right there. So if you guys see issues like that where you're like, no, it is, I see it. Like I can see that it's happening, but the computer doesn't see it. So that's something to keep in mind. We're going to continually go over scope. I think it's kind of a fun, interesting thing to kind of just touch on occasionally, but that's not what we're focusing on right now. So it's a little sidetracked on scope. Get rid of that little secret. Okay, we're back into our function. Okay, so yes, Kyra is correct that we could return the beans here like this, but What if we wanted to pass the beans into the function? What if we said, you know what, I want to actually put the beans in the function and then have them go through the function and get spit out. Do you guys remember arguments and parameters? Does that ring any bells?
Yeah.
Okay. So arguments and parameters are pretty much the same thing. They just have a different name depending on where at what point in the flow they're being used. So if we were to put something in here, what would we do? Could we put a variable in here?
Oh,
Joseph, you don't think so?
yeah, the function's not set up to handle an input argument.
Okay, okay. That's true, yeah. So the function is not set up to handle an input argument. So if we wanted to do that, if we wanted to pass some beans into our function as a argument here, could we change this function so that it accepts a parameter?
Yes, the parameter is any bean, right?
Okay, yeah, it could be anything. So let's say we just call it anything. So this is where now we have a function that accepts one parameter or accepts an argument. Don't need to worry too much about that differentiation at this point, but basically this is like a little placeholder that says, like something goes into me. Like this is like, imagine like a hopper on top of a coffee grinder, or imagine a hopper on a paintball gun. You know, like if you had a paintball gun that didn't have a hopper on the top, and all you could do was like disassemble it, put 3 paintballs inside of it, close it all up again, and then you shoot 3 paintballs and you're done. It only gets what it had from the beginning. You couldn't actually put anything in it. You know, like if you wanted to put any different color of paintball inside of it, you have to put a hopper on top. And then in the hopper, you can dump whatever you want in at whatever point in time. And then you can shoot it.
Strictly adhere to that though, because you still grabbed any bean from the main scope. So how do you make strict about that?
Yeah, we are changing the function right now. So sorry if this is a little confusing. So instead of returning any bean, because if we return any bean here, we're not actually doing anything with this anything parameter here. So we could return anything. So if we return anything, we're saying, here's a machine that has a hopper. We put something in the top. I don't know what it's going to be yet, but I want to be able to accept something into the top of this function. So you put something in, and then I'm going to give it back to you. So now at this point, we're saying, okay, cool. Like the machine is set up to accept the beans in the top and then do nothing with them, but spit them back out, open the door and give you the beans back. And the cool thing is we could put any bean in there that we want. So before, when we returned any bean, that was assigned to, the variable names are making this a little confusing, sorry, but before, any bean was assigned to Arabica. So it was only ever going to return Arabica no matter what we put into the hopper, into the parameter here. So if we want this to return Arabica, we would put any bean in here, right? So now this is where things get a little confusing, where this is an important concept to grasp, but let's go ahead and clear our console and just run this really fast and see what happens. Okay, so we got Arabica returned from here. Now the magic piece here is that we are, when we call the function, this is when we're saying there's a machine that exists. I'm going to flip the switch, turn it on, and do something with it. And that's what we're doing on line 23. We're saying, okay, let's run this function, and I'm going to pass in, this is me dumping the bag of Arabica, because that's the value of this variable, into the top of this function. Now, when we do that, this parameter, which is also a placeholder, it's easy to think about this as a placeholder. So parameter P, placeholder P, this parameter becomes what you gave it, basically. So when we return anything here, now at this point, anything has become the value of any bean. Does that make sense?
Oh, yeah. Yeah, because, yeah, so the parameter or placeholder is anything. And so when you call the function, you're deciding that that parameter is going to be any bean.
Mm-hmm. Exactly, yeah. Yeah, so it becomes that.
Yeah.
Travis, I know this is, and Kyra has been learning some of this stuff. So I think her, brain is more primed to accept insanity. But it's tough. It's
After
really
a lot
hard.
of suffering.
Yeah. So this is one of those things where like,
yeah.
it usually takes. Go
Can
ahead.
you just say it again?
So yeah, no worries. Let's call this function call. And then in here, we're going to console.log inside the function. So we're not even really using the, we're not even really using the parameter here, but we just want to console log to kind of see the timing of everything.
Yeah. So that's going to print. That's going to print function call
actually,
first.
This is a little convoluted because of this.
No, it's helpful actually.
Is it? Okay.
For me.
So let's.
Yeah, go ahead.
No. I was just going to encourage you to do what you're already doing, to run through line 15 through line 27. Let's think about this from computer vision, like what's happening.
Right. So it's gonna see the function being declared. It's gonna say cool. Awesome. It's gonna jump to line 26.
Yeah.
Print function call, print last, and then go back and print inside the function.
Okay, so.
Or is it going to print last first and then go back and print function call and then inside the function?
So when we hit line 26, let's rewind to line 26 really fast. So when we hit line 26, we hit our invocation, right?
Uh-huh.
Where this sends us back to which line? Like at which line does this execution happen? Like where does
18,
this function
line
call
18.
go to? Yeah,
well,
exactly.
Line 15 is already read, and then it goes inside of the function.
Totally, and that is a really crucial like little piece of understanding that a lot of developers don't even realize, is that line 15 already happened. That was just the remember part,
right?
You know, and you're totally right that now we go into line 18. That's awesome. So then we hit line 18, and what happens?
And then it's gonna log inside the function.
Okay. Yeah, so we see inside the function. Great.
And then print function call, because you're returning something which has been defined as, or not defined, invoked. Wait.
Exactly. Yeah. Yep.
Is that the terminology though?
This function was invoked.
Yes.
And we passed in, we say passed in. You remember all these things start with a P: parameter, passed in, placeholder. Yeah. We passed in function call as a string.
Okay.
Something became that, right?
Yes.
At this point.
That is my understanding.
And I guess I shouldn't point to line 15 because that has been read already. It just knows that will be there.
Yeah. But then when you return something, that's function call, because that's what you assigned that value.
Mm-hmm. And I probably shouldn't have made that string function call. That's confusing. This is all just, I'm overly confusing this. I should have made it some gobbledygook. But yeah, you're totally right. This is awesome. So crushing it. So line 20 is going to do function call. Then what happens?
And then it'll print last, because that is not related at all to that function.
Because it's done. Yeah, because we returned. And the return statement is basically saying I'm finished. Like this function is done. This value is opening the little plastic door. Here's some stuff. Like go back to what you're. Awesome. So let's see. Let's clear our console and let's do this. So we just used Travis as our computer instead of the computer, which is awesome. So yes, Travis, you were totally right. That is how this runs. The reason that this is because for some reason the return value wasn't, like, maybe this only prints to the console when it's the only thing in the function. I don't know. That's some weird thing about the snippets thing. That's a snippets thing, not JavaScript. So don't worry about that. Okay. So we console log something there. Even if we removed that, it would be the same. But you were totally right. So we have inside the function call last. Awesome.
Thank you for going through that.
No, this is huge. This is huge. These are huge concepts to get. And Joseph, I know you're, familiar with some programming stuff, but did this make sense? Is there anything you wanted to go over again? And just the only way to really, really drill this into your brain is just do examples and get a bunch and then do it together. So, and if I hope you're following along too, if you can. So, but Joseph, any questions, any thoughts?
Yeah.
What's up?
What if we had some functions do math, like addition, to show it doing stuff, and then also handling scopes with those variables?
Handling scopes with the variables?
Yeah, so
absolutely.
You might expect the number 3, but it's actually the number 2 because it's a different scope. That kind of like addition function.
Right. I see what you're saying. You don't think that would be a little potentially confusing to?
More confusing to show a function that takes an input and then just returns it, because mentally you'd kind of ignore that and go, well, we give it literal something and it returns literal something and it didn't do anything for us. So it kind of like makes you want to block that out. So
okay, I like it.
Work for us.
Let's do 2 examples. Let's do a function that is going to manipulate numbers like you were suggesting, and then we'll do a function that manipulates strings. So, okay. So first of all, do you want to, Joseph, do you want to pseudocode with me? Do you want to try to drive? So let's say we're using let as our variables here, and let's write.
Yeah, we'll have like XYZ variables.
Okay. Just tell me what to write, what letters, what to type. I'm your hands.
Let X equal 1, let Y equal 3, let Z equal 0.
Okay.
And have like we want the console or our output or some kind of print to show like X plus Y. So we expect 4. And then we might have a function called add to.
Okay, how would you write that?
Let add to equal our number.
Okay, so
our num.
Oh, okay.
Yeah. And then function body.
Or function body like this.
Yeah.
Okay.
And then just have like return our num plus 2.
Okay.
And then like call add to on X, call add to on Y. And then what numbers do we expect to see? There should be 3 numbers that come out when we run this.
Okay. Perfect. Does anybody see any issues before we run this? The big red X. Spoiler alert.
Yeah, something's red.
Is it the space after our num?
Mm-mm.
Hold on. So
It's not the space after our num. I'll scroll up here a little bit to give you guys a little secret hint.
Oh, the parentheses.
We are missing parentheses, and Joseph, there is a caveat that maybe you know about here, that there is one fancy way you can actually remove parentheses from an arrow function, but let's not worry about that right now. We do need parentheses for our parameters. So where does the parentheses go, Kyra?
It would be let add to equal and then parentheses and then equal our num.
Like this?
Yes.
Close the parentheses, do a fat arrow, and no. Open and close the parentheses around our num.
Ah, okay.
Oh, so the our
And
And then
num
the fat
is
arrow.
the
Yeah,
param-
there we go. Okay.
It changed colors. Does that mean it's right?
And it changed colors. Yeah. Joseph, does that make sense?
Yeah, the function syntax is set up.
You have me write Python over here, bro? Is that what you're doing?
And then, yeah, I'm not sure what the console or this tool will do since.
Yeah, you know, so this is an easy way to do this.
We don't have variables set. Yeah, console.log, since we don't have variables.
We can just console log the whole function.
How did you just type in 2 places at once?
Oh, dude, all kinds of business. You hold command. So command gives
thank
you
you.
multiple cursors. Command, clicky, click, click. And this works in VS Code.
Command
What
clicky
was that,
click
Joseph?
click.
You have 2 keyboards.
Yeah.
Yeah, exactly.
And 4
As many
hands.
keyboards as I need. Cool. All right, Joseph, awesome. This is a pair programming collaborative function right here, baby. Everybody wrote this function. Love it.
Let's publish
Okay,
it. Let's
so-
get read.
Yeah, exactly. Let's put it on NPM. All right, cool. So we are. I don't want this to be confusing. Does this make sense to you guys? So we are using console log just to see what happens when we invoke add to, passing it the parameter of x.
Yeah.
Does that make sense? Okay. Sweet. So let's talk about what's going to happen, Joseph. Since this is your function, let's think like a computer. Let's go through 27 through 38.
Well, we have 3 integers declared and assigned. And
Okay.
we're just straight adding 2 of them in JavaScript. And then we have a function that's also doing that.
Okay. What is this? What is line 31 going to give us? What's our expected output?
4.
4.
Okay. Cool. All right. Great. And then line 33. Keep going.
And then that will depend on what we give the add to function. So we don't know until we
Okay.
pass variables into it. So we can never guess what that'll be.
Okay. Perfect. Yeah, that's great. And one way we kind of have been talking about this is that on line 33, we are declaring add to, right? And then assigning it to a value of what? What is the value of add to? Or the type, sorry, not the value, the type.
Ooh,
It doesn't have
And so like up here, these are numbers. So like
Yeah.
these are numbers and, you know, integers, as Joseph said, the type is an integer, type is number. And then the add to, it actually does have a type. And when I say type, I'm not talking like fancy type, but just, you know, what kind of thing is being put into the memory of the computer when we say let add to equals this? What is add to?
It's an object.
Technically, but we're not talking about objects yet.
A variable?
It is a variable, and it is assigned to
Our num.
Fun.
But our
Our-
num doesn't have a value, which is why
Right.
I'm
Sorry,
confused.
I won't let you guys play too much more. This is assigned to a function. So add to is a
Okay.
function. The type of,
Oh,
if you were to run
okay.
type of add to, and this is something that is fun, is if we were to do, there's actually something in JavaScript called type of. I think it,
Oh.
is it all lower? Yeah, it is all lowercase. Okay, and then just space, add to. This will say function.
Oh, okay, cool.
So see that?
Cool.
Type of add to is function. So yeah, so we are putting a function in memory. And the cool thing about what we just did here is we console log type of add to before we invoked it. So this is basically asking the computer to tell us what it remembers about this before it's been invoked. And this tells us that it doesn't know, like Joseph said, it doesn't know what we're going to pass into it. It doesn't know what's going to be returned. It doesn't care. All it knows is, oh, it's a function. You know,
Yeah.
this other thing, this is a number. This is a function. Add to is a function, and then it keeps going. So
So if you
that's a
put
little
in
bit of a,
type of X, it would be integer.
yeah, let's do that. It's actually probably going to say number with a capital
Or
N.
number. Yeah, sure.
But exactly, or lowercase
Okay.
n. We're all wrong. But yeah, so the type of that is a number. So let's try.
Cool.
Let's see. What do we have up here? So we have like, let's try any bean. What do you think any bean's going to give us?
String.
Okay.
So here's what I wonder: is JavaScript going to help us, or is it going to concat a string with 2? If we put a bean into add 2.
Put a bean into your machine. Oh my goodness. Now we got the coffee machine, and then we got Joseph's crazy mad scientist machine. We're gonna put beans into it. I love it. That's a great question. I love it. I think we should try it out. Great. So, Joseph, let's continue. Sorry, I derailed this a little bit on line 33. So on line 33, we add a function to the memory of the computer. We say add to is a function, remember that. And then we jump to line. I'll let you go ahead, Joseph, sorry.
Jump to line what?
So on line 33, when the computer is reading through this, it says, remember add to is a function, right? But it isn't, the function hasn't been executed, correct?
Right.
So because it's not executed, it sees that it's a function and it ignores this as far as execution goes. It doesn't actually even know what's inside the parentheses or what's inside the brackets here. It just knows that this is a function and it moves to line 37.
Yeah, and then we have console log to like print stuff.
Mm-hmm.
So if like line 39 was console.log add 2, and then it was any bean instead of
Okay, now we passed any bean in there instead of y.
Instead of y. And I'm wondering what that would do, because we don't really tell the function to be strict about numbers.
Mm-hmm.
So I don't know what will happen.
This is a fun little experiment. All right, so save it. And let's run it. Okay.
Yes, I knew
Arabica
it.
2. Oh, is that what you're gonna say, Kara?
Yeah, it was supposed to be Arabica 2.
Oh shoot, I'm
Yeah.
sorry. I should have given you a second. But yeah, Arabica 2 gets
4,
spit out.
3, and 5 are our numbers, though.
Yeah.
Yeah, exactly. And the reason is because, so we see what we got for add 2. X.
Yeah.
X was 1.
Add
So then we had
2,
1.
and it equals 4.
1 plus 1 for X. 1 plus Oh, sorry. Yeah, it's this one. It's this one. It's X plus Y first.
Oh, which does equal 4. And then
Yeah, so we first console logged X plus Y. Yeah, I was like, what? 2 plus 1 is 4.
makes sense. But I'm okay. Here's where I'm confused.
Yes.
X equals 1, Y equals 3, Z equals 0. I understand that. Print
Okay.
X plus Y equals 4. Understand that.
Okay.
Let add 2 equal parentheses our num. Okay.
Mm-hmm.
Return our num plus 2. Never mind. I just answered my own question. Okay, so add 2, when we do console log add 2, oh my God. Basically,
you can
my
ignore
brain.
console log.
No. Because I'm thinking in terms of. I think I answered my own question. Because where I was getting hung up was our num didn't have. I don't know how to explain what I was thinking, but I think I understand now.
You don't see our num declared anywhere. Is that what you're wondering?
I think maybe that's what my brain was getting hung up on. But then add 2. Yeah, that's exactly it. It wasn't being declared anywhere.
Exactly. Yeah. So our num is placeholder is not the technical term, but remember we talked about P's.
Yeah.
Parameter.
Thank you. Yep.
So our num is a parameter, which is kind of descriptive in the sense that, like, you know, it is going to be something. Like, there are some parameters that we set, kind of, and it's like there's one thing that goes in here, and in this case we haven't really, you know, we're not forcing it to be anything in particular, but we are calling it our num because we are planning on passing a number into it. But then Joseph just threw that all out the window and threw a bean in there, and which is not a number, which is why we got Arabica too. And Joseph is totally right. So Joseph, what did you say this was called again when you were adding a string and then sticking something on the end of it?
So it's concatenating them. The number behind the scenes is turned into a string. That way they can both be concatenated together.
Exactly. So this is where JavaScript is trying to be helpful, and this is why a lot of people hate it. Like, I would argue that you know, lots of people would say that should throw an error because that's stupid. You know,
because you can't
these are
add an
done.
integer. Yeah.
Exactly. So what that is called, oh man, this may be a little bit, you can totally forget what I'm about to say because this is just fun, but that's called type coercion, which basically means it's like JavaScript is a really just like a bully, and he's saying you're not a number two anymore. Now you're a string because you've been forced to get with our note to Arabica, and then it just coerces it into becoming a string, which is something people really hate because they're like, I want my types to stay the types they are, which is the reason that something like TypeScript exists, which you may have heard of, which is just it's a framework for JavaScript that makes it more strict, basically. But yeah,
So
totally right.
Can I ask something real quick? And this might be way too advanced for what we're doing at the moment, but console.log on line 37, you're printing add to parentheses x. So add to is the function on line 33 there. Yes. Right? Mm-hmm. Yep. So is the computer taking the number 2 first and then adding it to x, or is it saying x plus 2? Does that make sense?
Yes, it definitely does. So what the computer is doing is you kind of want to think about the thread, like think of a piece of thread on a needle. And as it's going through, you know, we hit line 37 and it says, okay, console log, so that it knows what it's about to do. It's about to take whatever is between the two parentheses of console log, and it's going to print that value to the console. Right. So if we didn't return anything out of add to our function, it wouldn't print anything because there's no value to be printed. So it says, okay, I'm going to print something. And then it says, okay, add to. So then the needle and thread goes into add to, and it says, this is a function. It goes back up, threads up through into line 33, and it says, all right, let's see what's happening here. Sorry, I guess technically line 34. And it says, all right. It says, okay, return our num. Our num is a parameter. I know what the parameter is because you gave me x. X is, and then it goes back up into its memory. And let's pretend that, you know, line 27 is the memory for where it is, but really it's just on the computer somewhere. So it threads back up into 27. It says, okay, x is a 1. Okay, cool. So it goes back down, swaps the x out with a 1. It says, I know what you are. Let's add 2 to that, x plus 2. Cool. All right, x plus 2, which at this point is now 1 plus 2 is 3. Sweet.
But it's actually printing plus 2 plus 1.
Sorry, can you say that one more time?
I guess I'm maybe it's a matter of semantics, but line 37 to me is saying the parameter of add to is affecting the x rather than saying x plus 2.
I have an idea.
Okay, I can kind of see what you're saying. So, okay, go ahead, Joseph.
So what if like line 36, we say let result equal 0. And then right below that, do result equal add to x. And then line 40, replace console.log with result.
Why is result 0?
just to initialize it.
So in JavaScript, we don't have to assign it anything because we can just declare it and it just is undefined already at this point. So at this point it's been declared, but its value is undefined because it hasn't been defined and assigned to something. So we could do it this way. But okay, I see what you're saying. So then now you're saying drop this and just do result.
So now we're typing out each step rather than wrapping them all together. So we've broken
and let's
what it's doing.
Yeah, that's a good point. So then actually we could just could we do this, Joseph, do you think? Would this be
Oh yeah.
simpler? Okay. So what Joseph was doing, Travis, is trying to make this visually more clear because we're using console log to just spit out some values here. And that might be part of convoluting the problem. So now he's just saying, okay, we're assigning a variable result, which is a great variable name, to the function add to when we invoke it, like whatever this value comes out to after it's been called.
Okay.
Does that make sense?
Yeah.
Okay. So add to, it takes x. X is a variable
1.
here, which is 1. So it's basically like saying add to 1.
So
that's really what happens.
and this is can we print this real quick?
Yeah.
But this is what I'm asking.
Do you want to do it this way?
Either
or
way.
with this as an
Either
X?
way.
Okay, let's put the X back. Save it and let's run it. Okay, sorry, let me comment this one out. Let's clear it again, just to make sure it's nice and clear.
Okay. So this isn't my question. This doesn't answer my question. Basically, what I'm asking is semantically, the computer. I'm basically talking about the order of operations, right? I'm saying, is 2 coming first or is X coming first in the computer's mind?
X is coming first.
And that confuses me. Because when you invoke add to, or when you're, sorry, you're saying let add to equal our num. Our num is whatever is in that bracket, right?
Our num is nothing really at this point. So remember when we're talking about order of operations, we are, you said the variables make sense. We put those in memory. We assign those. We tell the computer to remember them, right? And then when we hit line 33, we're doing the same thing, but instead of assigning a number to add to, remember that we're assigning an entire function.
Yeah.
Right?
Yeah.
So as the computer is running through this file initially, it ignores this. It ignores the function. It just remembers that it is a function. That's it. So it doesn't know about our num at all. It doesn't care at all. This is a parameter that will be used when the function is invoked.
Yeah.
So we say, okay, X is a number, Y is a number, Z is a number, add to is a function, result is, then it says, okay, now I remember add to is a function. Now we're going to use it. Now we're invoking it. And then it says X, I remember X is 1. X is now 1.
Right,
and it
but
says,
you're
okay, cool.
You're invoking the function first, and then you're putting the variable. Oh man, my brain for some reason is not connecting this.
Okay, so are you kind of thinking about it this way, where like it says let result equals add to, and then as soon as we hit this first parentheses, it's like we haven't even hit the X yet, and we're already in the function. Is that what you're saying?
Yeah.
So I could see that confusion because you're saying, how does it know that X is 1 if like when we invoke it and we go right into it and then we say our num here? Like, is your question the disconnect between X and our num?
No, I understand. I understand that. Those are
Okay.
completely unrelated. It's just that X is becoming part of that. X is becoming that.
Yes.
Or the whole thing, really. But what's can you start a new line real quick? And I'm
Yeah,
just going to
definitely.
try to explain to you where my brain is going. No,
Do we wanna do a
not
new
even
function?
code wise. Not even code wise. Just it can be a comment. I just want to.
Okay.
So what I'm seeing is the computer says X equals 1. I'm trying to think of how to explain this. Hold on.
Should we totally like pseudocode this?
If you
X
want,
is 1.
I don't know. Maybe this is completely unimportant, but what I'm seeing is the computer says X equals 1, and then it says add 2 is a variable or is a function.
I'm going to change this to remembers. Is that okay?
Yeah, that's fine. And then it says let the result be positive 2 plus 1. No, and this is important. Positive, yeah, exactly. Positive 2 plus 1 rather than 1 plus 2, which is what I would expect from. God, this feels completely pointless. It feels
No.
I just want to know what the computer is reading on line 37. Because I know
Okay,
that
on line
I know that
37.
we're invoking the function. I know that I got that. I understand that X is being recalled from line 27. I understand that add 2 as a function is whatever we define it as on line 37, which is, or sorry, our num is
Our num is whatever we want to give. So on line 37, we're giving X, or we could give Y, or we could give Z.
right.
So we assigned our num to X, and X is
Right.
assigned to 1.
So I guess that what I'm saying is X is 1, but it's coming after a positive 2. So positive 2 plus 1 rather
Travis,
than.
maybe I misspoke earlier because remember when we threw the beans in there and it
Yeah.
printed Arabica 2?
Yes, that's confusing
So-
to me.
But you were expecting 1 plus 2, right?
Yes. Well, but that's the thing is I expect it logically in my brain to be 2 plus 1. Positive 2 plus 1. Because we have said our num plus 2, right?
Yeah, but what is our num?
X.
Which our num is X. And what is X?
1. So
Yeah, so our num and X are all 1, basically.
right. But add 2 is coming before the variable in line 37. That's what's screwing with my brain.
Okay, I see what you're saying. So, okay, so there's, when we talk about parameters and placeholders, so we talk about up here, this is a placeholder, and its cousin is X over here, right? And what this is called an argument. And maybe I shouldn't have glazed over this because I didn't want to over confuse with too much terminology, but arguments and parameters are cousins. They're very, very, very closely related. They both fall between the parentheses of a function. That is, and a parameter falls between the parentheses of a function as it's being declared. A argument falls between the parentheses of a function as it's being invoked. Those are the two differences, the crucial differences. So they're very, very similar.
Okay.
And they represent, like, when everything is executed, they become each other basically, if that makes sense. But this is an argument, which is basically like dumping the beans into the top of the hopper, if that makes sense, where it says, it doesn't have to be a variable. This could be 600. And it's still an argument. The argument is then 600, but the arguments change. Arguments change as the function is invoked,
Yeah.
So we could invoke this function as many times as we want with all different kinds of numbers. If that makes sense.
It makes sense. The only thing, so if you printed that, it would be 602, 57 or whatever it was, 50.
Yeah, it's not gonna like this result thing, but yes.
Anyway,
let's do it.
But if you put a string in one of those, like if you, in the last one, you just put Travis is asking too many questions, it would be Travis is asking too many questions 2.
Yeah, because of the order of line 34 of how it's concatenating it.
Got it. And that's what is that line 34 defines the order, not line 41, which is ultimately what, and that's ultimately what is that add to coming before whatever gets put in the parentheses was very confusing to me for some reason.
No, that's totally natural. I mean, these are, first of all, if you have any understanding of algebra, this complete, which is confusing because this is not algebra at all. Or even, I mean, there's arithmetic being used by JavaScript, but it's not algebra.
Yeah.
So yeah, this defines the order of, we'll just say that. This defines the order. So that is where the order happens. And I'm wondering if,
another way to make it verbose
is
like if inside the function, instead of shortcutting that return line, we do like temp, let temp equal 0, and then temp equals rnum plus 2, and then return temp to like kind of show the whole thing going. So that's the same thing. It's just a shortcut to say return rnum plus 2 instead of writing all those.
Yeah.
Yeah, is that helpful? I never know
Very.
if things like, okay, so thank you, Joseph. That's a good point. I never know if breaking it out like that makes it more confusing or less confusing.
No, well, this whole conversation has been helpful for me because the only thing that was screwing with me is the difference between 34 through 36 and 40, 41, 42, 43, like where the order was coming from. I was trying to think like the computer.
No, which is great. These are the important pieces because you're not going to have knowledge gaps if you ask those kind of questions and you really try to understand all those small pieces.
Yeah,
which is awesome.
I guess the shortcuts like that make it confusing and should be working backwards, where we write it like it is now, run it, and then erase everything and just show return rnum plus 2 to like show how you can shortcut the actual code.
That's a great point. I like that. Yeah, because I actually forget that, because we are learning variable declaration, variable assignment, all of that stuff at the same time. So yeah, I could see. Yeah, you're right. You're right. I didn't even think about that. So yeah, breaking it. I'll make a note of that for the next lessons. But making it so the more verbose, where it's even if it's multiple lines, as long as the lines are like simple and like they encapsulate something that makes sense and something we've already learned, that makes it easier to read through. It sounds like.
You're asking me?
I'm asking everybody. Yeah. So like basically what we did here, like Joseph's great idea, breaking lines 34 to 36 out more.
Yeah, I mean, it was helpful for me only because I wasn't connecting everything.
think that's good. I'm going to do that more where I try to at least, yeah, like Joseph was saying, make it more broken out rather than bringing things all together at once.
Should have started with that and worked backwards. Sorry about that.
Mm-hmm. No. I mean, this is all a learning experience, and yeah, it's difficult. I mean, I'm trying to find out the best way to present these things, and it's hard to remember like all the things we're trying to learn at once. And I know this is so much to throw at everybody. So, Kyra, how are you doing? I think you're good. Are you good?
Sorry, I completely derailed the lesson.
No, it's just the four of us. You're good, man. We're learning.
No,
Kyra, you're muted. I think you said you're good, but
to ask all those questions.
Yeah, I'm good. Sorry.
yeah, don't stop asking questions, man.
Yeah.
So what we are going to do now is thank you, Joseph, for helping me with that. That's awesome. That was some great input. Okay, so now we just have our beans, and we're kind of off the rails as far as the actual lesson plan goes, but I mean, as long as this is still helpful for everybody, I don't really care that much. I guess we can kind of hop back into like what I had laid out here a little bit, where we were going to talk about, and so Joseph had a great example here where we did some we did mathematics, where we added numbers together and we got some outputs, and we actually got to see some fun little concatenation as well. So let's do another function that basically just works with strings. And we can kind of just look at the same problem from a little bit of a different perspective and hopefully get more of a three-dimensional view of it. So let's recreate our function here. And I'm going to go back to the coffee machine thing just because that's what my notes have. And this was going to just use strings. So we're going to do our mega coffee machine equals, assigned to the function. And then fat arrow, lest we forget the fat arrow. Okay, sweet. So now we have a function that is assigned to the variable mega coffee machine. So mega coffee machine is a function here. Sweet. The next thing we need to do, what do we write if we wanted to invoke this function? And then invoke, trigger, parentheses.
Wouldn't that give an error because it doesn't have anything?
Right.
So Joseph, you're thinking this would
Sorry.
give us an error? No, Travis was right.
I was saying parentheses.
Yeah, no, I saw your hands. I saw your hands go up. I accept the answer. So Joseph, you think this might give an error?
Yeah, I don't know. It's just very empty.
Yeah,
It is empty. It is empty.
Parameter.
Okay, let's see what happens. Okay, I ran it. We didn't get anything. Undefined by default just spits out here as the first piece. So we didn't get anything happening, which makes sense, right? Because we aren't trying to, the reasons we would get an error is if we were trying to access something that isn't in memory, something that doesn't exist. And what we've done here is we say, hey, mega coffee machine is a function. So this little mega coffee machine is assigned a value function. So it's a function, it's in your memory. Boop. It remembers it. Then we say, hey, mega coffee machine, invoke that function. Mega coffee machine is a function. It is an empty function that does nothing, but it is a function, which means that it has the ability to be invoked. So then we invoke this function that does nothing, and then the function does nothing and nothing happens, and it's all over. So we don't get any errors because JavaScript doesn't need anything else to be valid at this point in time. It doesn't need anything else to actually run, and it is running. It's just not doing anything. So this is not a problematic piece of code. This is just code that does nothing. Does that make sense, Joseph?
Yeah.
So I would recommend, and personally, this is my personal preference, I like to start when I'm writing functions, I kind of like to start things this way, because this is a basic beginning point where we have a parentheses where we can put in our parameters or our arguments. We can add things to it. We have the beginning and end parentheses, or the beginning and end brackets, so we know where everything is. So this is kind of a good way to start out and say, okay, I'm calling the function, and then I'm building it. So you could very easily add to this, and say, okay, if you were adding to your function, and then you saved it and ran it, then you already are invoking it, so you're going to get something spit out here. So here we're going to get blah spit out because we're invoking the function. So if we didn't invoke it, we wouldn't have this. So I kind of like setting things up initially like this and then writing the content and the body of my function. So let's get this function back to kind of where it was before. So we have beans. Beans is when we put beans into this part of our function declaration, our function definition, what are they called here? What is this called at this point?
Parameter.
Yeah, it's called
Okay.
parameter. So this is a parameter here. Now, if we wanted to give beans meaning, first of all, let's set up a console log so that we can see what it is. So now we are console logging the parameter. Now, if we wanted to give beans a meaning, to make beans something, what do we do? What do we add?
What?
What would we have to add?
You have to put in a what's it called? You have to invoke it.
Okay, yeah, so the function is being invoked. Yeah, and we're real close. You're very close because it needs to be added to the invocation of the function. So it goes between the parentheses. And what could it be? It could be anything at this point, right?
Right.
So what do you want it to be? What do you want beans to be at this point?
Tasty.
Tasty.
Can be, yeah, a string of tasty.
Sweet. So what is the string tasty? What do we call this here? So remember how we were talking about two things that are cousins. So we have the parameter, which goes up here. And then this down here is its cousin that is very closely related to it, that has a different name when we invoke the function. Does anybody remember? Yeah. So this is the argument. And you think about like an argument, like you're always arguing for something, and now we are arguing for our beans to be tasty. So the argument is a string, tasty. So then when we invoke this, what do we get console logged?
Tasty.
Booyah. Yes, we do. So we get tasty. So what else could this be? So this could a variable, right?
Yes, it could be fancy coffee beans or any bean.
Yeah, let's do fancy coffee beans. We haven't used that one much. So because fancy coffee beans is just a string, pretty much the same thing as what you're doing here with taste. It's just pointing to another place in memory. Does that make sense?
Mm-hmm.
Yeah.
So now fancy coffee beans is Sumatra. So we're going to get Sumatra back. And maybe I will move this down here so it's in view, so it makes it a little bit clearer. Sumatra. Awesome. Okay, so now let's do some stuff. Let's do some concatenation. So we're going to make a variable here. This one is going to be, unfortunately, I have to do a let, called your drink. So your drink equals, here's a tasty cup of, and we can do concatenation here. Does anybody remember how we did concatenation? And concatenation is basically, plus, okay, awesome.
And then what are we concatenating?
So let's concatenate in, we basically want to say this here. So let's finish out our little sentence. We're going to say coffee, enjoy. So basically we want to print out and say, here's a tasty cup of blank, your coffee, like whatever your coffee is called.
So
Enjoy.
it could be.
So you can put fancy beans or whatever.
Yeah, any bean.
So this is a good, yes, this is a good question though. So if we put fancy coffee beans here, how are we, well, first of all, what would this print?
Here's a tasty cup of Sumatra coffee, enjoy.
Exactly. So here's a tasty cup of Sumatra coffee, enjoy. Awesome. But where does this break? How does this break down? Let's say we wanted to put in any bean here. Now, what does this function do?
It just,
Because what's it going to print? What will it print out?
it's gonna print Arabica.
Okay. Can you run through that with me and tell me why? Because online, we really just have to think about line 59. We invoke our function, and what's happening on line 59?
Because, because you didn't, when you invoked the function, instead of the argument being your drink, you just put Annie bean. So the computer completely ignores line 59 because you didn't use that as a argument.
You're very close. It doesn't have anything to do with your drink. Let me go ahead and return it, just so that makes sense here. Then now we're going to return that string that has been assigned to the variable your drink. So it doesn't specifically have to do with the variable your drink, but it does have to do with what's happening inside of this function. So
would it put,
Travis,
would it print out, here's a tasty cup of Sumatra coffee, enjoy, but then it would also print out Arabica?
Okay, you're getting a little closer. Travis, I saw you nodding. Do you see anything here?
I was nodding because I was like, this is exactly the question I had earlier. This is going through
Okay.
exactly what I was confused about.
Let's run it. Okay, so we got
Sumatra.
something that says, okay, where's the Sumatra coming from? Hold on. Fancy coffee beans, fancy coffee.
56.
I don't know why that is. We're not. That might be happening up here. Maybe that's just,
What's your question?
Oh, I'm interested why that printed. Oh, interesting. Okay, that was an old problem. I don't know why it printed Sumatra. Okay, so we got, here's a tasty cup of Sumatra coffee, enjoy. Is that what we wanted to happen when we changed it? Because look at line 63, remember?
Were we wanting to replace fancy coffee beans with any bean? Is that what we're trying to do?
Pretty much, yeah. And I'm going to put this down here as well together so we can look at all of this at once. Okay, so this is what we're looking at here. Yes,
So,
Skyra, you are correct.
The way to do that would be to, instead of having fancy coffee beans in the concatenation, replacing that with Annie bean. But are we trying to make it so we don't have to replace it and it just does it like automatically depending on what we?
Yeah, because our function doesn't really, it's not very powerful if we have to actually change the inside of the function every time. That's not leveraging the power of functions.
Okay.
And we're not even using the parameter at all right now, right?
Right.
Can you have multiple parameters?
You totally can, yeah. That is not necessary right now because at this point we're taking one action. We say you put a parameter in there and we want to be able to print this sentence with an infinite amount of coffee types. If they invented one tomorrow, we want our function to be able to say, here's your tasty cup of new strain of coffee, enjoy. Right? And we can do that with parameters.
With parameters, okay.
That's the power of this parameter. So I want this to be able to say,
could be something like coffee type.
Sure, yeah, let's do that. We can change that. So coffee type, that might make it easier to think about.
Okay, now let's see.
And anybody else, feel free to jump in if you guys see something you want to talk about.
I'm
first of all,
interested to continue this train of thought.
Okay, let's talk about the problem statement really quick. So the problem statement is we have a function, right? We have a function that returns us a sentence, and it says, here's a tasty cup of Sumatra coffee. Kyra wanted to change this to any bean to see what happens. So let's go ahead and clear our console and run that. So now we have a function. Yeah, exactly. It says Dunkin' coffee, enjoy. But if I change this and I say make a coffee machine and I pass in fancy coffee beans now, what is going to get printed in the console?
Here's a tasty cup of Dunkin' coffee. Enjoy.
Exactly.
Well,
But
so
we
this-
changed what we.
Sure. Can you define a parameter?
So parameters don't really get defined in the sense of a variable. Parameters are used, and the way they get used, remember, is with what we put in there when we call it. So we
Right.
called the function and we passed in fancy coffee beans as an argument, and then the
Mhm.
argument replaces the parameter.
Okay.
It flows through the function in this way. So
Okay.
what we're missing one important piece here, because we want this function to be able to change depending on what we pass it.
Yes.
And we're not using something at all that we should be using to make this function change.
Which
the-
we
the
used
key is that-
earlier, right?
I should know.
Yeah, we were doing it a little bit earlier. So this is a static function at this point in time. Does that make sense? Because every single time we call it, even if we don't pass anything to the function, it's going to print, here's a tasty cup of Dunkin' coffee,
Hmm.
even if we don't pass it anything. Oh, sorry, I did not do that. There we go. Here's a tasty cup of Dunkin' coffee, even though we didn't even give it an argument.
Right. Because you put
Let me
any
know when you
bean
want me to jump in.
in the.
Yeah, exactly. Travis, you're definitely on the right course. We have to use our parameter.
Oh, you instead of plus any bean, do plus coffee type.
Yes, exactly. So we
Yeah,
weren't
okay.
even using our parameter before, because coffee type, this parameter is the power. This is where everything
So
our function can
then
do.
when you call the function, you can do fancy coffee beans or any bean
Mhm.
because
Mhm.
then it's saying, it's doing like we discussed earlier. It's kind of like
Replacing.
shape shifting or whatever.
Exactly.
Okay.
Yes. So out of curiosity, since we already had this one before, what will this print if we don't give it anything?
Will it?
Will it print an error?
It won't print an error.
Or
But coffee type-
Will it
undefined?
do? Here's a tasty cup of coffee. Enjoy.
Yeah, exactly.
Oh, okay.
Of undefined
Undefined
coffee. Yeah,
coffee.
close. You guys were both
Undefined
right. Kyra
coffee.
said undefined and
Gourmet.
Travis
That's-
explained, yeah, of undefined
That's a
coffee.
really good coffee bean name.
Yeah, exactly.
Undefined.
And that's because coffee type didn't really have a definition, it didn't have an argument passive. And Kyra, you just asked, can you define a parameter, right?
Right.
So in a sense, using an argument
Is
is
defining a parameter,
defining a
yeah.
parameter, because we're defining it and we're saying it is fancy coffee beans. Cool. So now we get a tasty cup of Sumatra coffee. And then let's say we wanted to use our function a second time, and this is where it gets really powerful, is we don't have to rewrite a new function that says, here's a tasty cup of Sumatra, here's a tasty cup of Dunkin', here's a tasty cup of blah, 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 and return all that. We don't have to rewrite this whole function over and over and over again to greet people with what kind of coffee they're getting,
Right.
or to let them know what kind of coffee they're getting. We can reuse our function by passing it different values, as many as we want.
Yeah.
So
okay.
now we get, here's a tasty cup of Dunkin' coffee, and this is that console log thing. So let's do it one at a time. So any bean, here's a tasty cup of Dunkin' coffee. All right, awesome. Now let's see fancy coffee beans. Here's a tasty cup of Sumatra coffee. And if we added a new one, or even if we said, you know what, that's a brand new bean, and we don't even have time to add this, to make this a variable, I just need to throw it in directly, because I'm only ever going to do this one time.
Mhm.
You know, this is like a, one of a kind bean. We could just run that once.
Yeah.
And say, cool, here's a tasty cup of one of a kind bean coffee, because we didn't even need a variable because it only happened once. We could do so many things with this function now
Mhm.
because we're just using a parameter. We're using the parameter.
So this might be like a next week lesson, but could you set it up to where you can say like line 66 is fancy coffee, line 67 is any bean, line 68 is a different kind of bean, on and on and on, for however many types of coffee are in the machine, and then have it so that if you ask for a certain type of coffee, it'll print that type.
When you say ask, what do you mean ask?
Like if a user comes in and so we're set, I'm speaking kind of practically, like the practical application of this would be the coder goes into the computer and says, here's all the different types of coffee that are in this machine. And then a user comes by and pushes the button that says Sumatra, and then the console prints, here's your Sumatra coffee.
That's so funny.
Would you use arrays?
You could use an array, yes, but we're not quite to
for the
arrays yet.
coffee types?
Because we haven't even talked about conditionals yet,
Yeah.
which is exactly
Which is
what
next.
you're talking about. Which is part of what I hope we're learning. Are we learning?
I'm learning.
Yeah.
So, but yeah, that's exactly what I was going to do. We are going to be using a drop-down menu where you can select what kind of coffee you want, and then when you click what you want, it prints out onto the screen and it says, "Here's your tasty cup of Sumatra coffee. Here's your tasty cup of blah, blah, blah coffee." Totally, we are going to do that, and that's exactly what we're talking about. And we're going to use conditionals to make that happen. So,
Gotcha.
The next example I was going to use is cream. If we wanted to add cream to our coffee, so at this point we have an awesome function that takes in a parameter, and we're using our parameter, which is really, really dope. Now let's say that we want to make this function, this coffee machine, do more, because currently we have a coffee machine that only gives us black coffee. What if we want people to have the option to put cream in their coffee, right? We could do, and Kyra alluded to this a little bit earlier, we could actually add another parameter, right? We haven't really talked about this, but functions can have as many parameters as you want. They can have tons and tons of parameters. So the only key piece of syntax here is a comma. So we have coffee type and we have cream.
So then when you invoke the function, you would put as the arguments any bean, comma, and then cream.
Yeah, we totally could. So
Okay.
any bean, and then we wouldn't want to do it this way though, right? Because then it's looking for, what would it be looking for at this point when it says, okay, any bean, I know what that value is, and then it's going to say cream.
It's looking for the parameter. Oh, wait, no, it's looking for a variable of cream, which doesn't exist.
Exactly, totally. It's going to say cream is not defined. So we could do this, Kyra. We could make it a string for sure.
Okay.
Which we could do that, but we could also use another JavaScript type. Remember the flipping, the heads or tails, the coin, where it's only one or the other. Do you guys remember what a boolean looks like?
Oh, it's the thing, the 2-bar thing.
That one's an or statement, which we are going to talk about later. But booleans are just true or false. So we could make this a boolean and say, you know what, cream is either a yes or no question. You know, we don't care that much about our users to make the cream specific. It's just yes or no. So because cream is a yes or no question, it's totally something that could just be a boolean. So when we call our function, we say, you know, what kind of bean is it? And then yes or no to cream. And we say, okay, cream is true here. Sweet. Does this make sense so far, guys?
Mm-hmm.
Yes, but is the computer associating the argument true with the parameter cream?
How would we check that?
Console log cream, and then it should print true.
Exactly. Yeah, we totally and this is awesome. This is how we want to develop. We say, I make a change. I think this is going to happen. Let me verify. Run it. If it's not, figure out why. If it is, you can continue on. Awesome. Okay, so we get true. Here's the taste. Now let's make this false, right? This is a good way for us to just triple, quadruple check. Make sure that it's running as we expect. False. Here's the skip. Awesome. Okay. So that's working correctly. So that, if we just like take a look at it, this is pretty sweet. Like we have a function, and like I hope that this gets the gears moving a little bit where you're thinking like,
wait, so sorry.
Go ahead. No. Go.
So if you wanted to add a string saying like, here's a tasty cup of, coffee type, enjoy, but you could like if they decide they want cream, would you have to do in the function return
User selection
no.
or something?
If cream is equal to true, then return here, with cream or whatever.
Yes, that is where we were going. And yes, I love it. I love it.
Okay.
I love it. Okay. But just so we're not dragging anybody else along, this is where we're going to go with it. So here's your tasty cup of coffee. And let's just say with cream, let's add that to the string here, right?
Okay.
Enjoy. So anybody point out the problem here though, okay? Because this is similar to what we had before where we're kind of stuck.
The problem is that it's always going to say with cream, but if a user doesn't want cream, we don't want this string to say with cream.
Exactly. They're always going to have cream at this point, right?
Yeah.
So we're not really paying attention. We're not using this parameter because remember at the beginning, we weren't using this first one and now we're not using the second one because we just say with cream all the time. So this is where Kyra's totally right. She's ahead of the game. I love this. This is where the answer comes in, where really, if we just say this out loud, we say, if they want cream, we put cream in their coffee. Otherwise, we give them black coffee. That is a conditional. That's what a conditional is. And it looks almost like what we just said out loud, which is really cool.
Oh, so is sorry. I'm kidding.
No. Go, Kyra, go.
So is the let your drink equal blah, blah, blah. Will that be in an else statement?
Totally. Why don't you go ahead and write it? Yeah. So and the syntax for if statements is really simple. So this shouldn't be too difficult to remember or to practice at least.
So if and then parentheses, right? Yeah. If cream is equal to true.
How do we need to do a deep equality equals?
2 equal signs.
2 would work. 3 is better.
3, yeah. True.
Okay.
Okay, and then the brackets.
Okay. Let's pause really quick though, because this is new for some people. So this is a conditional. This is it. That's it. That's all you have to do. You just say if, then you put your parentheses, then you have an open brace and a closed brace. So we created a block here. We actually created a little bit of scope too, which we talked about earlier, which is cool. But that's it. That's all you have to do. And does this make sense? Like, can you guys take a guess as to how this works? Where all of the code between those curly braces only runs
if the statement is true.
If what's in the parentheses is true. Exactly. If it evaluates to true. And that's kind of why I went with the Boolean, because I kind of was, you're thinking ahead, you're thinking, oh, I'm probably going to use an if statement. They use Booleans. They require a Boolean between those parentheses. It's something that evaluates the true or evaluates the false.
Right.
Okay, keep going, Kyra. That's all. I just wanted to mention that.
So then you would put let your drink equal. Here's a tasty cup of coffee type with cream. Enjoy. And
yes.
then you would put else.
Okay, and this is we are now expanding on the syntax of a conditional. You don't always have to have an else, but you definitely can. So
else.
Sorry.
Go ahead.
Because I see exactly where this is going. My question is, could you do if cream equals true, let your drink equal, here's a tasty cup of coffee, blah, 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 and then do another if statement and say, if cream equals false, here's your tasty cup of black coffee, enjoy, and then have another one that says else, print, you didn't order any coffee or whatever.
Yes.
Okay.
I love it. Let's let Kyra finish her else statement, and then we'll have you write the extra pieces we want to add in. Awesome. Okay, Kyra. So what do we do here?
Else, let your drink equal, here's a tasty cup of coffee type, enjoy.
Awesome. Okay, and I'm just going to copy this and edit it really fast.
We forgot to add the return your drink on both ones, on both conditionals.
Ooh, okay. I like it. Is that how normally a tasty cup of? Oh, whoops! I forgot to put coffee. There we go. Yes. So that is true. Okay, let's do that. And then we're doing return
Yeah.
Sorry, hold on. Okay, so then return your drink. This is what you wanted to do, Kyra?
Or I guess you technically don't have to do it for, oh no, I'm not sure. Yeah, and then
No, go ahead, think through
delete
it.
the last, the bottom part. Yeah.
Okay. Travis, does this still work with what you wanted to add?
Oh, no. Everything's cool. I was just saying, can you have multiple if statements? And then the other question would be, do all of the if statements have to come before the else? Or can you say, if cream equals true, if cream equals false, and then else you didn't order anything, or whatever? Or does it, or can
That's a
it
good
be
question.
if else and then another if, if no input, print or let your drink equal you didn't order coffee?
Yeah, so we can do that. And there's a few
Okay.
questions in there that we definitely want to answer. So first up, I love you. You literally said what the syntax of this is. So first of all, if you can do multiple ifs, and you do that like this. So you do else and then if like this. So else if is actually its own piece of syntax here.
Gotcha.
So, and then and usually people like to stack them like this. Like they like to stack the else and the else if on the previous end bracket, if that makes sense. The reason it's throwing an error here is because it doesn't like an empty if statement, because this is always this is just like, doesn't do anything yet. So, so this is the syntax here, else if. And actually in, I think it's Java and maybe Python, Joseph, you have to correct me if I'm wrong. Their else if is like a single statement like this, but in JavaScript it's two. So else, and then it's just another if, basically. So you can chain as many of these together as you want.
Python abbreviates it to elif.
Oh, elif, cool. And Joseph, sorry, I didn't want to plow ahead. Do you have any questions, or did you want to clarify anything or talk about anything?
No, I'm just waiting for you to get to the return part, how that could be.
Okay. Yes, there is more. What is that called when we take a bunch of code that could be shorter and more concise and make it better? Anybody know? We haven't talked about this.
Know this.
Condensing?
Totally. It's like an industry term for condensing. It's just making your code more efficient, more readable, and less prone to bugs. Because the more lines of code you've written that you could make shorter is just more lines of code for bugs to hide in. And it's called refactoring. So we refactor our code. Okay. You basically just, and this is my approach. Not everybody does this, I don't think, but my approach is to write it the way it works. Use your, think about the problem, write something that's just going to get you there. Just get your problem solved, and then look at it and be like, oh, that's dumb. Why did I do it that way? I could have done this and this. And it's a lot easier to see the big picture when your problem is already solved and then make it better. So that's called refactor.
I have a question. You're saying let your drink twice. Is that going to cause issues with two lets again? That's
a great question. Yeah, it's possible. I'm thinking maybe we should
No.
Do you guys want to run this first and see what kind of errors we might get, or do you want to go ahead and run Travis's piece?
Let's run it without line 66 and then add.
That's awesome. Great. Yeah, that's a great point. And I'm glad you guys chose that option, because that's always good, because this is where you can get stuck, where if you add too much code without running it, you don't know where your error is coming from. You don't know where you made your mistake. Okay. So what do we get?
Dunkin' coffee.
Yeah, because cream was false, so they didn't want any cream.
Yeah,
that's pretty sweet, right?
Yeah, that's cool.
Okay, now let's try it again. And now what do we expect?
Here's a
Dunkin' coffee with cream.
Yeah.
Cool.
Okay, so let's go back to Joseph's question. Joseph said, are we going to run into problems because we're defining your drink twice? That's really intuitive, and I love that, because are you allowed to declare two let variables back to back, or one after the other? You are.
If it were
the same,
that would be different.
Great, that's great thinking, and I love where your head's at, because true, the main difference between let and const is let can be redefined and const cannot be redefined. But the key piece of that is that const can be assigned to a new value. So you can take a number and you can make it a string. You can take a string and make it a different string. Sorry, I mean let. Let can be redone. Const can't, but you can't have the same exact name. So if you did let x equal, you know, hey, let x equal blah, this actually isn't something you want to be able to do. And it even knows before we run it.
Could you, if we were to switch the else and the if statements, and then you had let your drink equal this string plus coffee type, and then in the else statement, you could be, if they want cream, then let your, or let, no, never mind. Or
I
no.
think I know where you're trying to get to.
Like you could
and we
like
can
your
definitely
drink plus and then the string with cream.
And what is that called again, Kyra?
Concatenating.
Yeah, string concatenation. Exactly.
Yeah.
Totally. And that's refactoring. So we can refactor there. Let's save it until we have it working the way we want. But going back to this, you may be thinking, but that's a let, not a const. Why could we not do that? The reason is because if we wanted this to be a different value, you need to reassign it, not redeclare it. You have to say x is already there, x equals this. By doing this, you're not allowed to do this because when we run line 80, it's basically saying x is in memory. Like this thing is in the memory here, and you can't use that same exact piece of memory for the same exact name of a variable with a different value. You just need to reassign it. So basically, you only declare your variable with the same name once. So that's why Joseph's question is definitely valid. Now, the reason we don't run into that issue is because these two blocks of code are impossible to both run consecutively.
Right.
That make sense? Does that make sense, Joseph?
Yeah, it's if or else. It's not ever gonna see both declarations.
Now, I do agree with Joseph, though, that I think this could be a little bit cleaner, and I think it would look better if we do only declare your drink once, and then we change its value. We redeclare it as we go. That's refactoring, something we can do afterwards. So let's go ahead and do Travis's else if statement in here, though. So we know that it works. That's awesome. So let's throw another else if in here, and now we're talking about doing. All right, sweet. Okay, and what was it you wanted to add in here?
So actually what I would do, my thought is to have that last statement, that else statement, be the else if, and then have the else statement be no,
you're good. Go ahead, keep going.
Well, I'm trying to think of what I would do. I would do else. Well, we would have to define another variable for what I'm trying to do. We would have to say no input or no user input or no coffee, and just say else if no coffee order, let your drink equal you didn't order anything.
Okay, great. So you want this to trigger when they don't put in a coffee type. Is that what you're saying?
Right.
Okay, awesome.
Or if there was like a random bean variable and say whatever.
Okay. So we want to say, so let's break it down first of all, just the thing you want to happen if there's nothing put in here is let's just put that string in there. Let's just make it exist. So you want to say, if they didn't order any coffee, what do you want to say to them?
You didn't order anything, or you didn't order any coffee, whatever.
How about checking the coffee before the cream?
Okay, checking the coffee before the cream. Okay, great. So Joseph is saying maybe we could make that even better here by saying if coffee doesn't exist. And you guys, we've seen this before, right? Where if we didn't put anything in here, what would coffee type be in this function? Like what if you were to do type of coffee type and you never passed anything into this function, like if we just invoked it like this, what would coffee type be? Undefined. It wouldn't be defined at all. So we could do that. So Joseph, do we want to do that first right now, or do we want to maybe save that for refactoring?
Save for refactor.
The only reason I say that is I don't want to overly convolute it and get confused on what's going on here. So
Yeah.
but you're definitely right. You are right. Sorry, I don't want to shut you down there, but we say, okay, if cream true. So we have this block, this works. Let's leave it alone for now and fix it later. So we say if cream is true, copy with cream. Awesome, cool. Then we say else if.
Would it be if coffee type is equal to null and cream is equal to false, and would be the two and symbols.
Great. Okay, so that is
well,
new.
but that's in the last statement, right? So this would be if else if cream equals false, let your drink equal here's a tasty cup of whatever coffee.
Right.
And then the last one would be what Kyra was saying.
Okay, I like it. Awesome. Else if cream equals false. And then do we need to make this an else if, or can we just say
just else?
Wouldn't it just be else?
Okay, awesome. So you didn't order any coffee. So this is where conditionals add a lot of power to our code, but they also have bugs. So this is when things really start, you're gonna actually be debugging things, because you're gonna say, oh, that didn't work the way I expected it to. Because when your code is making its own decisions based off of inputs, sometimes you don't foresee all of the paths that could happen. And that's where things get fun and interesting and useful, but also you can have a lot of bugs to hide. So this is great. So how do we want to test this out first? What do we want to do here? Do we want to, sorry.
Call the function with different arguments to see if it's working properly.
Awesome. Yeah. Okay. So let's do fancy coffee beans. And do we want cream or no?
No cream.
Okay. So let's do false. Okay. So let's save and let's run it. Sorry, and let me clear that out so that we can make sure we got. Okay, yeah. So here's a tasty cup of Sumatra coffee. Enjoy. Great, that did work. Okay, now let's try it. True.
Any bean and true.
Ooh, and now we're gonna do any bean. Okay, awesome. Save, run. Okay, hold on, I gotta still run a little slow. Okay, here's a tasty cup of Dunkin' coffee with cream. Enjoy. That's awesome. Now, how do we test the last one?
Just don't put anything in the parentheses.
Okay, so if we just stood at the order counter and didn't order anything.
But we still gotta add parameters. Yeah.
Undefined. Oh, so would it?
It's undefined because there's no.
You're not calling anything.
Oh, I'm sorry, guys. I'm sorry. We didn't put the return statement in here, huh?
Right.
So we have to return something. That's why we didn't get anything, because it didn't return anything from the function.
Oh, so it will work because it's literally anything else aside from what we put as conditionals. It has to print. You didn't order a copy.
Yeah.
But you don't have to put cream is false and copy type is null because it's already going to assume.
And if you had done that, you would probably be able to come back and say, oh, I could probably switch the order and make this less complicated. You could refactor your code. We can still refactor our code here. So Joseph, why don't you jump in and help us refactor the return statements? So we have 3 return statements, and we're defining this your drink variable, multiple times. So how can we make this better?
You could get rid of all 3 return your drinks and put 1 at the very bottom after the else statement closes.
Okay, I like it. So return your drink.
Because the 3 we choose, we're setting that variable. And so it's going to return whatever it ends up as.
Okay.
I like it. Should we run it? Do you think this will work?
I think so.
There are some bugs. Let's see.
Your drink is not defined.
Oh, so we have to define your drink somewhere else
When we say
In-
somewhere else,
in the function.
okay. Now,
Oh.
does everybody, why did this happen though? It's because of scope.
Yeah, because it's your drink is defined within the the conditional statement.
Mhm.
And so when the computer reads it, it's reading it, I guess. What am I trying to say? What I'm trying to say is if we were to define your drink outside of the if conditionals statements, then the computer will be like, okay, your drink equals this. Now we can go through and.
You're definitely right.
So you have to do that before before the function.
Not before the function, inside of the function though. So so remember when we talked about the soundproof room? Go ahead, Joseph.
Well, part of the bug is our conditionals are based on the input parameters, and on line 79 we have no input parameters to run conditions against.
So that is intuitive, but coffee type and cream are of the type undefined. So we are able to say, is cream true? Well, that is not true because it's undefined. Is cream false? That's also not true because it's undefined. And undefined is not equal to the Boolean false. Because false is a type. It's a type of Boolean. Does that make sense?
Yeah.
So talking about scope, the reason that this is happening is because when we look at curly braces, I really want you guys to think about these are called blocks. When we see an opening and a closing curly brace, if statement, function, object, anywhere you see those, it is creating scope. And you can think about it like creating a little soundproof room, okay? So we have this soundproof room. We have this soundproof room. And we have this soundproof room. Any variable that gets declared inside of this little room, no one hears anything else happening outside of it, right?
Yeah.
But they're inside of their own little soundproof rooms. And these are kind of like, maybe a soundproof room is a bad metaphor. It's almost like a one-way mirror. Because you can see, go ahead, Kyra.
I actually, you're so, but I think I know how to refactor it.
Oh, okay, awesome.
But
awesome.
Yeah, go.
So I just want to make sure that is kind of clear. So we see that this bracket here. So see this whole function. This is its own little room with some more rooms. And let's use one-way mirrors as a metaphor. So these guys can't see into here, but if we define a variable in this room, in this big one, they can see out of their windows. These little rooms can see outside and access what's just one level out in this room here.
Yeah.
So it's kind of like this nesting. It's like a nesting of where things are accessible from. So Kyra is right. How can we make your drink come back as being defined?
It would be let your drink equal, here's a tasty cup of,
okay.
Hold on. Yeah.
We could do something fun here. We could really spice this up by using variable reassignment. How could we use variable reassignment to make this work?
You would, so it would be let your drink equal and then like a string, but then when you go inside the conditionals, when you're returning your drink, you would do return your drink plus, and then coffee type or whatever.
Okay, so that's a possibility. Can you guys hear me okay? I just had to switch AirPods.
Yeah.
Okay, so that is a possibility. We get into some funky territory there though. So let's try it a different way. So we declared your drink to be an empty string here at the top. So that way it's defined. So it's not going to come back as undefined. But let's think about how we can fix this with reassignment. How could we use reassignment to make this less repetitive?
I have a question.
Go ahead, Joseph.
So within that if statement, that let your drink is not scoped to the function. It's only scoped to that if statement.
Yes. Yes,
Oh.
you are right. The reason that it worked was because we were returning inside of that block, inside of our if statements. We had 3 return statements, remember?
Yeah.
So that's why that worked. But we can use this kind of one-way mirror because Kyra's now defined your drink in the bigger room, in the bigger scope here, where these all have access to looking outwards. Now, I guess I'm gonna give this one to you guys. Is that okay? Or do you guys want to keep?
Please do.
Okay. So we're gonna use variable reassignment to make this happen.
Yeah, so your drink, when you set it to an empty string, that means when you reassign it, it will just automatically be whatever string you give it.
It gets replaced because that's how
Replaced,
reassignment
yeah.
works. It's replacing the value empty string with here's a tasty cup of Sumatra coffee with cream, or here's a tasty cup of Dunkin' coffee, enjoy, or you didn't order any coffee. Does this make sense to everybody?
Yeah.
So all you did was define your drink as an empty string within the function. And
Mhm.
then instead of using a let statement within the if statements, you're just
Reassigning.
calling your drink.
We are not calling your drink, we're reassigning it. It's just
Reassigning
like
your
line
drink.
56. So take lines 56 and 57. These make sense?
Yeah. Yes.
It's the same exact thing as this
Got it.
down here. So we can refactor this by just doing that a little bit.
Got it.
Does that make sense?
Yeah.
So Kyra, what this is doing now is this saying, let your drink be remembered. Your drink is in memory
So then
as
you could technically
undefined.
have it be any type of
Exactly.
variable then.
Because, and why could it be anything?
Because it's just saying let your drink be whatever your drink is.
You said the answer in that sentence on accident. It's because it's a let instead
Oh,
of
it's a
const.
let. Okay.
Because it's allowed to be anything you want it to
Got
be.
it.
And I didn't know this would happen, but you also moved the scope of it.
Exactly. That's what Kyra did.
Mm.
Yeah.
By moving it out one level outside of those if blocks, we now are able to use it. Does that make sense?
Yeah.
But
Which is so fun.
yeah, okay, sorry. Go ahead.
Now, just one more piece to kind of touch on scope again. If we were to do this, what do you think we would get? This is outside of our whole function.
Undefined.
Travis, what do you think?
I knew you were going to do this, and this is actually what I was going to ask. I think maybe it'll print all 3 options.
Ooh,
It
okay,
would
interesting.
I feel like it would put undefined if you console logged it outside of the function, but if you console logged it inside of the function, then it would print.
Because you haven't defined. Oh, maybe it will print undefined. Because you haven't defined your drink as anything. I think it'll print undefined.
Undefined outside, but if it were inside, it'd print null.
Okay. I love the gears turning. This is awesome. This is great. I want to go to what Travis said when he said initially he was thinking it might print your drink 3 times, right?
Mm-hmm.
You did mention that. I don't know. I don't think that was final train of thought, but this is all about scope. This will print undefined because this is a one-way mirror. When we're on line 77, we're outside of this function. Looking at this function is like it's encased in mirrors. We see a big box that just reflects our current place. We can't see inside of it, but we can see outside, you know, like you can almost think of this like a lens. Like see how the little pointy guy points like out? The pointy guys point out. they can see out, like almost like like you ever seen a crawdad trap where they crawl through those holes and
Yeah.
then once they're stuck inside of it, they can't get back out. It's like that. So we cannot see inside this mirror box where your drink is. So this is going to be undefined because this is all secret to us. This is all blocked away. It's scoped
Yes.
separately. It's hidden from us. Now in here, if I was to say, let blah equal something else, and then I was to go outside of these if blocks, console.log blah,
It would be undefined.
Yeah.
it's also undefined because of the same exact concept, because we can't see inside that if block. We have
Right.
access to your drink because we're inside of the function, but we don't have access to blah because we're not inside of the if block.
Yes.
Now, this is super, super, super helpful because of what Travis had said about like, oh, maybe that would print all three, which without scope, it would, because they're all just conflicting with each other and it's just a mess of stuff together. We have to have separation of things, and we have to have, you know, safe spaces where we can do things and make changes and assign values and then hand them off to its outer scope to then have something happen with them. So without scope, an if chain like this, a conditional chain of if and else if statements is it completely falls apart without scope. We need scope to make this work. So this is a great example, and I'm glad we built it this way. I'm glad you guys built it this way so we can talk about scope a little bit. Scope is really complex, and we're going to continually talk about it. And it isn't something that's immediately going to just click. And if it did, then you guys are geniuses. It's awesome. But do you feel like you kind of have a nebulous mental model of how scope might be working?
Oh yeah, for sure.
So let's run this really quick just so we can see what we got. Sweet. Didn't run. Hold on. There we go. Here's a tasty cup of Dunkin' coffee with cream. Enjoy. So we know what is going on here. And now, okay, we're like 1 minute away from being done. So thanks for bearing with me. But you know, like we had done before, we could do so much stuff here. And one of the things that I had like in my notes was let's make it let's add. I want you guys, if you have all this stuff written down, and I'll send this code to you. But maybe you could add a functionality to say, how do we handle decaf? What if somebody wants to put, you know, call decaf or ask for decaf coffee? You know, how could we do that? How are some ways we could solve that problem? So if you guys have time, I'll send you this code. I'm going to bundle together kind of that little piece of homework a little bit more carefully.